So the last thing we're going to talk about in this section deals with percentiles. So when we talk about a percentile, we're talking about really taking a data set and splitting it into about 100 groups with 1% of the data lying in each group. You've seen percentiles before. You may have seen it in some kind of standardized test that you took, like if you took a high school EOG or ERC, and they tell you you are in the 75th percentile, then that means that you scored better than 75% of people who took the same test, and 25% scored higher than you. You may have seen it with growth charts. My child, for instance, is in the 32nd percentile for height, so she's a little short for her age. That means that she is taller than 32% of kids her age. She's 4, but she is shorter than 68% of kids her age. So percentiles are used a lot in a lot of different places. So what we want to do is take a data set and we want to figure out a couple of different things. We want to find a percentile of a data value, and that's what we're going to look at first, and then we're going to figure out some other things. So bear with me as we go through this section. So we have a set of data values here, and these are actually the number of points scored in Super Bowl for a period of time, 24 years to be exact. We want to figure out the percentile corresponding to the number of points. So the first thing I want to do is kind of split this up so it's easier to look at. We have 24 values here, so we have 12 values in the lower half, and 12 in the upper half. So that's where your 50th percentile would fall. And then we're going to split this again. I'm going to go, I now have 12 here, so I need 6 in the lower, 6 in the middle half. I need 6 here, and then 6 here. So I'm just splitting that into chunks to make it a little bit easier to look at. So then 47, we're asking what percentile corresponds to the value 47. Well, here's the value 47. So we've got to figure out how many values are less than 47. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values less than 47 out of the 24. And we're going to multiply that by 100. So when I type that in the calculator, I got 37.5. That is going to go to a 38. So we're going to say that number 47 corresponds to the 38th percentile. And we can do the same thing with 65. Let's find the 65. Here it is. Now, how many values do I have that's less than 65? 6, 12, 18, 20. So we have 20 values out of the 24 that's less than 65. Multiply by 100. I got 83.3, which rounds to 83. So we would say the number 65 corresponds to the 83rd percentile. 65. And then we can do 54 the same way. So take a minute, pause the video, try that, figure out what the percentile would be. So here's our number 54. We have 12 values that are below that number out of 24 times 100. That ends up being 50. So the number 54 corresponds to the 50th percentile. So now let's go back the other way, and I've recopied the data set here just to make it easy to see everything so I don't have to flip back and forth. So I'm putting my same splits in that I had before. To convert a percentile to a data value, we need to find the location. And that location is going to be whatever that percentile is divided by 100, and we're going to multiply by how many values we have. So let's find P20. So we want to find what value in this list corresponds to the 20th percentile. That's what we're asking. So we need to find the location of that 20th percentile. So the location is going to be 20 over 100, and we're going to multiply by 24. So 20 divided by 100 times 24, I got 4.8. Which is going to correspond to the 5th value. So the 5th value is this number. So the value 39 corresponds to the 20th percentile. 39. So P80, we're trying to figure out where that 80th percentile is. Find the location. 80 divided by 100 times 24, since there's 24 values. Divided by 100 times 24 is 19.2. With these, you always round up. So this is going to be the 20th value. So that's a little tricky. Always remember that. So you may want to write that on a cheat sheet if you're preparing for the next test. So we need to find the 20th value. 6, 12, 18, 19, 20. That value is 61. So we would say the value of 61 corresponds to the 80th percentile. And then we need to find Q3. Q1. And there is going to be something with this one too. So remember, Q1 is the 25th percentile. It separates the lower 20% from the upper 75% of data. The lower 25% from the upper 75%. So let's find the locator. It's going to be 25 over 100 times 24. And I'm going to get 6. So notice that I get a whole number here. So anytime you get a whole number, you've got to find the mean of that value and the next. So here's your 6th value, here's your 7th value. If I find the mean, what's in the middle of 41 and 43, I would get 42. So the value of 42 corresponds to the 25th percentile, which is quartile 1. Now, that makes sense because of the way this data set is. So remember we had a line here. So we started out by splitting the data set in 2 pieces, right? So this was your median. And then we split that lower half of data into 2 pieces. So where that line is actually where your quartile 1 is, But notice that it splits evenly. We have 6 values in that lower piece of data, and then 6 values here in between quartile 1 and quartile 3. Quartile 1 has to live between those 2 values. Well, what's the middle of 41 and 43? Well, that middle has to be 42. So when you're using that locator formula, there are a couple of caveats, if you will. So first one, you're always going to round up. We got 19.2, and that last problem, we had to round up the 20th. It was going to be the 20th value. The other caveat is if you get a whole number. If you get a whole number, then you've got to find the mean of that value and the next. And that's what that percentile would actually correspond to. Just like we did here with that 25th percentile, which is quartile 1, actually lives between those 2 values.